This meeting is being recorded.
Hello, everyone. This is today's batch working group meeting. Today is 9th of June, and we have a few items in the agenda today by Diana as well as Aldo. So I'll give the stage to Diana, who's going to talk to us about MCAT.
Great. Can you hear me?
Yeah, we can.
Great. Awesome. I'll share my screen and then hopefully we'll get started here. I'll minimize all these windows here. Okay. And I'll go in full screen mode. Or attempt to go to there. I am. Okay. So hopefully you can see my screen. Thank you for allowing me to present this open source project that we've been working on. I'm very excited to be part of this work group because I think it's a great overlapping in some of the goals and challenges we're trying to meet. And so I'm really happy to be able to share some of the thoughts and ideas we had when we developed this open source project. And then again, being able to contribute some of the concepts and kind of drive some of these to the Kubernetes core system. So thank you very much. So the project that we have is called MCAT, Multi-Cluster App Dispatcher. And we started developing it to look at the challenges of Kubernetes dispatching specifically AI workloads to in a Kubernetes environment. And some of the key requirements that we were using to do the development was really to do some to be able to do some queuing for batch jobs, and then really build a framework where we can start applying various policies with regards to the whole life cycle of a batch job, not just the queuing, but the dispatching and then the preemption and such. So we had some initial requirements where we wanted to have some very basic policies where you could do, you can encapsulate a job and then assign a priority or a user priority for that, and also be able to do preemption with this job and requeue it. You also, one of the very first policies, which was, very obvious, which is really just enabling the ability to determine whether you can run this, all of the resources, all the compute resources this job would take, make sure that there's enough availability before you even start to create any of the objects of these jobs. And we first started out doing this on a single cluster. So we had the queuing where it would dispatch the batch job in a single cluster, and then we evolved it to where we can configure it so that you would have a queue in one major primary dispatching cluster, and you have these other sub clusters where you can actually dispatch the workload as well. We also added some abilities as we were working through the folks that were going to be using this, was being able to provide policies or the ability to do some aging jobs. And this is really to start to think about, you have some level of SLO that you're trying to accomplish, not just for, high priority jobs, but there could be some low priority jobs that you want to be able to do some sort of aging as it goes through the queue. And also we wanted to do some policies in regards to quota as well, specifically being able to do soft constraints and such that when there's low utilization on these clusters, there can be borrowing of quota. But obviously, as the system starts to have high utilization, we want to keep all the identified quota definitions within their scoped definition. And another key thing, which was really an interesting challenge, was that we were working with some existing solutions and services. And these existing solutions and services had Kubernetes, they were using for their batch jobs, other objects other than the actual batch V1 job object in Kubernetes. Some specific things they were doing was they were using deployments, taking advantage of some of the benefits there. And also stateful sets was an interesting challenge there. So what we were looking at and when we were evolving this is how can we support these solutions that are already using higher level objects that don't necessarily have run to completion? And how do you go about, actually queuing them up and actually running those objects that are inside of there? Any questions so far? Okay. Now, please interrupt if you do. Happy to take any questions. So as we develop this, one of the things we're also considering is that if we're going to evaluate these objects that represent a whole batch job, it's not just the pod creating objects. There's also custom resources that you may want to dispatch as part of the job, or they can be other non-compute creating objects, such as services, right? That's a common one. And we wanted to be ability to say, okay, all the objects to run this batch job that you're using, not just the deployments and then stateful sets and such, but also all the other objects you create. Let's go ahead and treat those completely as one entity. And the reason that we wanted to do that is that when we determine that the job is runnable, and I'm kind of highlighting the term runnable because essentially it turns into policies. But when a job becomes at the top of the queue and it's determined that it passes all the policies, then and only then do we want to actually create the objects that are that are wrapped in this app wrapper. And I forgot to mention, sorry, the custom resource that we built for MCAD, the definition is called an app wrapper. So we have all the objects listed inside the app wrapper, and we only want to create them when the job is determined to be runnable. I was really happy to see the fact that the same similar concept exists now today in V1, batch V1 job. So that was pretty neat, because basically the same concept where we're suspending the desired state until we mark the object where it's actually something you want to actually run the components of that job. So hopefully that makes sense. So we kind of have all the objects in the app wrapper, and all the objects don't get created until it's determined to be runnable. And as I mentioned before, once we actually determine that it's runnable, it gets dispatched, which means we just unwrapped all the objects, deployments, stateful sets, services, and actually called into the API to create them. Let's see. So as I mentioned earlier, the whole goal was to begin to create this framework so we can actually enable additional plugins and new policies, really more of like a life cycle management component for all kinds of policies that you want to consider. One of those we're considering right now is cluster scaling, similar to what I think Q has as well. What I wanted to be clear was we're not doing the same job as the scheduling as far as binding pods to nodes. We didn't want to be in that business because it already, it's lots of features that already exist. We just want to take advantage of those. So they've been totally out of the scope for this project from the beginning. Okay. Any questions? Okay, so just for a quick view of how things work. So we have the custom resource definition, the app wrapper. You put your objects all in the Kubernetes objects in the app wrapper as item lists. And then the controller that we have that is running is obviously operating on app wrappers. We also have a queue. It's a priority queue, so you can set priorities of the app wrapper and they'll be dispatched accordingly. And essentially, one of the first policies that I mentioned was the available compute capacity, right? So we don't dispatch the job until this default behaviors, it doesn't dispatch the job until we determine that there's enough compute resources to run all of the pods inside of that are expressed inside the job. And then, as I mentioned before, we actually transitioned from actually running it just in a single cluster. Now we can configure the MCAT controller to run in two different modes. One of them is what we call a dispatcher cluster or the dispatcher controller. As you can see here, what I'm trying to show is that these are multiple different Kubernetes clusters. The one where we dispatch workload to, we call them the agent clusters. They all three run the MCAT controller, but some of them run in an agent mode. Only one of them runs in a dispatcher mode, but the agents kind of feed available state or resources that are available to the dispatcher MCAT controller. All requests come into the dispatcher controller, and so the same queuing mechanism works. And you can also, once it's determined to be runnable, based on the policies, one of which is the available capacity, then it will get dispatched to the cluster, target cluster, and that target cluster will actually do the actual creation of the objects. Let's see, is there anything else? So I think that's it for that one. So as I mentioned before, we have this app wrapper that is a CR, and it wraps all the objects that represent the job. The controller picks it up, determines whether it's runnable based on the policies that are configured, and it does the inspection of that. Then once it's determined to be runnable, it basically just unwraps all of those objects listed in there and calls the Kubernetes API server to actually create them. If the jobs are not, or the app wrappers are not runnable, then we just requeue them. And again, we have some support of basically preempting based on priority and putting the job back into the queue. Okay. This is just a little bit more detailed example where this is in a single cluster. You would define, this is actually showing a custom resource. I'm not sure if folks are familiar with the Ray project, but we have essentially this is a custom resource that you list in the app wrapper. It eventually creates pods that are workers and header pods. But what you would define essentially is just the custom resource or the object you're trying to create. The controller will pick it up, determine if there's enough resources, and if it does, it'll actually create the high-level object you define. And that's kind of what I wanted to make clear is that we don't create the pods. We allow whatever object you're wanting to get dispatched. We allow those objects to follow whatever controller that's being used to create it, whether it's a custom resource controller or one of the Kubernetes one of the Kubernetes objects and the Kubernetes controller. Okay. Here's another example with a more complex, I think one of our services was a Spark job, and it had actually quite a few objects. This is just a subset of them, but quite a few objects that they were creating as one complete job. A couple of services, namespace, network policy. They had all those objects that they were using in Kubernetes to run the job. And so you just wrap them in the app wrapper. Before that happens in a multi-cluster environment, you start up all the MCAD controllers in their various states. The MCAD controller actually provides the state information from the agents and collects it at the dispatcher. So when this app wrapper that's over here to the right with all those objects that it wants to create gets submitted into the dispatcher cluster, the MCAD controller can then evaluate it, inspect it, determine it, and look at the available resources and the other agents, and then dispatch that app wrapper to the appropriate agent. In this case, the cluster that we sent it to was the cluster named Agent 1, and then the local MCAD controller running in agent mode essentially takes that app wrapper and then calls into the API to create all the objects. Okay. So as far as operational, we just essentially have the controller. We are transitioning so that we can start to have plugins for policy in the MCAD controller, but we also, support the Kubernetes scheduler, any custom or plugin scheduler, because all you need to do, which is what you normally do, which is annotate that in your objects that you create. So you can, pick up any scheduler that's you're already using, because those should be already annotated, and that should be as part of the definition you put in the app wrapper. Obviously, we're creating a lot of objects and evaluating them. So the RBAC configurations need to allow MCAD to do those operations on those objects. And currently, as far as our dispatching the project, there's no microservices or admission controllers. And then my final slide here is just to share some of the things I see going already and hopeful some additional things. I don't know how reasonable it is, but it was exciting to see the suspend for job. I think as people use some of these other objects, even though those objects are not run to completion, they use them in their definition of a job. So it'd be nice to see some of the other objects, with the suspend, such as the deployment, stateful set, where we can pause, the desired state management until we're actually ready to create all the objects. Multiple pod groups. So a lot of the folks that wanted to use this system, or I make an assumption that when they create custom resources, you actually have multiple pod groups, even though it's a group of one. So if you saw earlier, there was the array custom resource. They have one pod group, which is the header node, and then another pod group, which is the worker nodes. And those both make up a job. And so it'd be nice to see the multiple pod groups as either part of the batch V1 job, or maybe even consider another object that might manage those multiple pod groups. And that's my second comment, or my third comment, which is maybe in addition to, or maybe in place of having multiple pod groups in a job, maybe we may consider having a new object. I don't know. Hopefully we can kind of think through those things if we want to do that in this group. And also some of the features that we did, if folks find it useful to be able to create as part of the job, not compute any Kubernetes object that doesn't create pods. We may want to include them. I don't know if that would fit well with this, but that's kind of part of the job lifecycle management as well. And again, the multiple pod groups. And I think that's it. Any questions?
You're muted, Matt. While Maciek is trying to figure out his audio, I have a question.
Sure.
Um, um, can you explain a little bit again about non-compute resources? What's an example of that?
Good question. So these are non-compute compute consuming resources. So things like services. A great example of this is this one use case where we had all these objects that get created. Oh, two of them create computing consuming resources. Really just pods is really what that's intended. So
So would you want to like sort of pause any behavior before the the pods are created? Is that roughly what you're asking?
so uh, so one of the aspects is to consider all the other objects that are not part of that are not pods, and then actually pausing the creation of those until the job is ready to run. So that's one of them. And then, sorry, does that make sense or?
Uh, Roughly. So I guess in the case of service, for example, we would pause the creation of endpoints, but the service would still be created. Is that what you mean?
Oh, that's a good question. I've been thinking of them as only the pod objects, but I don't want to say, I think it's the actual creation. I don't want to say it. In on our mode, we don't actually create the service until the app wrapper is dispatched from the controller. So it's that kind of pausing and suspending that I'm thinking about, which is essentially don't create the object until you're actually ready to run the pods. So I don't know how it would manifest in the way that we've been able to wrap it, but it's a conceptual idea where basically don't create any of these objects until it's ready to run. In the concept of the job, I think from suspend mode, when you submit a job, none of the pods get created. So it's kind of like it's similar to that, but at a much different level where not only the pods are not created, but the related non-compute creating objects were not created also as well. Hopefully that helps answer your question.
Are there any more questions for Diana?
Okay, I'm gonna try once more. Can you hear me?
Yeah, we can.
Okay, I don't know what happened. I didn't change. So I wanted to comment on the extension that you mentioned. So out of the core resources that we currently have, deployment has the ability to be paused. We picked a different nomenclature to name them because given that they are a little bit different how they run, deployments can be paused. But I double checked if the other uh, uh, apps controllers such as daemon sets, replica sets, stateful sets, none of them has that capability. But I think adding those to be in par with the remaining apps controllers seems reasonable improvement that we can add, especially that over the past couple of releases, we are trying to align the controllers together. So adding the pause capability to the remaining apps controllers seems perfectly fine. And it will most likely will be called pause rather than suspended.
Okay.
Just tiny little difference. But deployments can already be paused, which basically means I can't remember what it does, but it will stop managing. Not sure if it will kill the current one. I didn't do it, so I don't remember.
That's great. Fantastic.
For your last point about job or something else, creating additional resources at whenever it's creating, that falls into some kind of templating mechanism. And for that, Kubernetes stayed away because the current mechanisms and the possibilities of using some kind of a templating mechanism that exists currently is probably broad enough that we didn't want to invent our own, especially that in OpenShift, we have a templating mechanism and it has a very limited set of substitutions and what you can do with it. And when we were initially discussing having similar functionality in Kubernetes, the discussion ended to be how broad set of functionalities within templating you want to have, whether we want to have just a simplistic, oh, replace these values with those other values, or you want to go further in, oh, I want to be able to conditionally add these or that elements, or maybe even one step further by allowing some kind of a functions within the templates. If you, and I totally forgot, there is a Python templating engine that I can't recall the name of it, but it has a very rich functionality when it comes to templating, including invoking functions, conditionals, replacing values, and so forth. So that was one of the reasons why we didn't want to have anything like that in Kubernetes, and probably will not. Yeah. And the multiple pod groups, if I remember correctly, we were discussing this. Wei was showing this on one of our previous calls.
Yeah, I remember that.
Yeah.
Yes. Okay. And so
But
go
I
ahead.
think you, by multiple pod groups, you mean like a single job has multiple templates, right? With
Yes,
different
that's
parameters.
right. That's exactly what I'm thinking about. Correct.
I have one other question, unless someone else wants to pose. Just to clarify, throughout your presentation, when you were talking about a job, that was a job in the sense of the multi-cluster dispatcher, not the Kubernetes job.
That's correct. I'm sorry. I
Yeah,
transition.
I kind of figure it out, but I just want to make sure
Yes.
that we're talking about different things.
Yes.
It's sometimes confusing when we
It
are
is.
using the same name.
Yeah.
Okay, cool.
Thanks for pointing that out. That's a great point.
Cool. Thanks, Diana. We'll move on to the next agenda item.
Okay.
We have Aldo wants to talk about retrievable, non-retrievable. I don't know if I'm pronouncing that correctly. Pod failures for jobs. So yeah, stage is yours. Do you want me to give you co-host?
Yes, that would be great. So I can present just the cap.
Sure.
I hope we have more time later to continue talking about Diana's presentation. We'll see. No. Oh.
Yeah, I think you should have co-host now.
Sure. Okay.
Aldo, I think you're mute. Sorry.
Aldo, what does it mean?
It's telling me that I cannot use audio when I'm sharing my screen.
Okay. Do you want to
Someone
share
else
the link?
had the same issue like 2 days ago. It was very weird.
Okay, I can just talk about it and then I guess the cap is visible for everyone. So sorry, I was saying that we're working on this old proposal for enhancing how jobs are retried or stopped. Currently, as you may know, a job only finishes a job finishes running when, well, it completes successfully or it reaches a back-off limit. The problem with the back-off limit is that all the failures are treated the same, right? So could be an infrastructure error where the kubelet dies, or the kubelet evicts the pod, or kubescaler preempts the pod, things like that. They all fall in the same sack as failures from the user itself, from the binary itself. So we want to introduce this distinction um, so that users have more control on when a job should finish or when we should just keep retrying indefinitely. So there are basically two use cases. From a user point of view, maybe you know exactly your exit codes from the one who wrote the binary. You might know exactly what exit codes you return. Some of them they are not retriable. Some of them they are retriable. So you can have that, but there is also another use case where you have an infrastructure provider, right? The university administrator of the cluster, things like that. You don't know what people are running, and you still want to provide, uh, non-retriable. You want to limit the retries for users, for user errors, but you want to make sure that if the infrastructure fails, they have enough retries, or simply the retries are ignored. So we're introducing this API in the job for you to define exactly which policy you want. If you can go down to the story number 2, maybe. I think this is the most a little bit lower. So
Oh, there you go.
the story in 2, that one. Yeah, the YAML. Can you go a little bit lower?
Yeah.
So I think maybe the most problematic API is this one. So I want to highlight it. The problem here is that, well, when there are exit codes, it's easy to manage. Kubelet writes the exit codes. But when there are infrastructure errors, they are not necessarily easy to identify. But currently, the kubelet introduces certain status reasons for when a pod fails. So we're hoping to add some rules based on those statuses. So yeah, the API suggested now is kind of a reduced version of label selectors or label matchers. So that's a proposal over there. And then one important thing to mention is the action. As you can see in line 383, there is the action, which could be ignore, or it could be terminate. So if the action is terminate, well, of course, the entire job terminates. And if it's ignored, it means that we simply don't even count this failure towards the backoff limit. So that's the mechanics of the API. Now, as I was saying, back to status reasons, the kubelet introduces status reasons, so that's very useful. But things like kubescheduler don't introduce status reasons today. Then we have, for example, the pod garbage collector that also removes pods. It also doesn't introduce status reason. So the second change in the API we're suggesting is to introduce a delete option in the delete API. Maybe if you can go to propose design details. Yeah. Yeah, design details, so lower. Yes, over there. So as you might know, when you're using the client to delete an object, you can set some options, and we are proposing that we introduce a reason there. So that the kube scheduler can introduce a reason for the failure, pod garbage collector can introduce a reason, things like that. And then in the job, you can use those reasons. So that's pretty much the entire proposal. There is a few risks. In particular, this reason is not very well documented. The reasons could change. Like we don't have a proper list of all the reasons that Kubernetes introduces, and it's not very well reviewed whether these values change and whatnot. So maybe the risk is over there. We'll have to enhance those their the reliability or the backwards compatibility of those fields. And maybe another question is what happens with index jobs. So in index job, you could have a failed index, but you still, I mean, it fails on a user error on a given index, but it might still succeed in the rest of the indexes. We are aware of that problem, but we want to start with something, so we'll deal with we want to deal with that in the next release as a separate cap. And what else? I think that's yeah, that's all the caveats I can think of. Oh, there is one more. You know, currently the pod garbage collector could delete a pod before we take a decision on the status reason or the phase. But since we already have finalizers for simply counting failures, we could piggyback on that to have more reliable accounting of failures. So that's all the risks I can think of. I would very much like everyone here to provide feedback on the CAP, on the API. And I will bring up this still to CGAPS next Monday. And I need to discuss with API reviewers because this reasons API might be a little bit tricky to support long term. But I hope that can all be solved before the enhancements freeze. Michał here is in the call as well. He's leading the development of this feature. So he's also here for any questions that you might have now.
So I have a question related to the status. Why is it specific to jobs? Like, can other workflow controllers take advantage of this?
No, I don't think so, because in the case of for example, a deployment where you have a service, you always want the service to be running, right? There is no end status of failure, at least currently. So it doesn't, yeah, you usually just want to keep retrying forever in other objects. And job is just different because it has to finish. But you know, if you can make a case for it, we probably have a look at it in a separate cap, not here.
Okay, you want to have it in a separate cap, like some of the things that I can
it makes sense. I don't think it makes sense today, but
yeah, I think one thing I'm thinking of is there are some states, especially since you're putting it at the pod level. There are things like, I think you remember the discussion that we had in CGAP's call a couple of weeks ago, where there are some stages where scheduler is actually putting it on a node and kubelet is actually trying to reject those things, and the pods would continuously try to come up. Can we do something? Can we do something in the controller which actually tells I cannot retry it because of this particular reason, and this is the reason that kubelet has set the status for.
I see. So the proposal here is to put these fields in the job API. The pod API is not changing.
I see.
The status reason already exists in the pod, and we are using that. And we're also changing the delete options API, but the pod itself is not changing.
I see. So when you put pod status, that's where I got confused. Okay, I'll look at the kept then.
I think in context to Ravi's question there, like what happens is for scenarios like this where the kubelet itself is rejecting pods, the scheduler doesn't have visibility into what has caused that. And it just repeatedly keeps placing pods, or if it's part of a deployment, it keeps placing the pods on the nodes. And there's no kind of loop back to the scheduler from kubelet. And this could be applicable to, I think, topology-aware scheduling is one of the things that where we are trying to solve this. It could be volume creation did not succeed, network creation failed. This, like, it could be applicable to a lot of scenarios, and to a lot of controllers in general, as Ravi was saying.
Yeah, I'm happy to discuss this in another meeting. I was talking about something very similar with Alexander, which I don't remember his last name. Yes, we were talking about the possibility of descheduling a pod. So the kubelet, because if you just fail the pod, then there is a new pod, and then we have lost all the information. So
yep.
He was suggesting, what if we just remove the node selector, but say, something failed, you shouldn't put it in this node again. But I think we're going off topic here, so we can discuss it in another meeting. Any concerns with the API? Do you think it's reasonable to rely on the reasons for this kind of behavior, for infrastructure errors? I guess silence seems means that it's all good. I'll probably have to justify it more with the API reviewers, but hopefully okay with it.
I think it was put in as a last minute item as well, so probably we haven't had the chance to review it in advance. Probably all the attendees can take a look and put some of their input into the KEP itself, and we'll do the same. So you should get some more input hopefully in the coming days.
Thank you.
Any questions for Aldo or maybe for Diana before we wrap up today's call?
I have one for Diana.
Sure.
Go for it.
Diana, do you think, so I think Q came later than your project. So do you think, is there a possibility of alignment so that
Yeah.
components of Q can be reused, or Q
I'm
can be
hoping so. I'm hoping so. So I think that would be really, really great. So let's talk more.
Yeah, let's keep the conversation open.
Sounds great. Thank you, Alex.
Cool. Thanks, everyone. Thanks for your time. Thanks for attending. Hope to see you in 2 weeks. People who have agent items in the future backlog item, if they can maybe start putting them as agenda items and preparing for them in the subsequent meetings, that'll be great. Hope to see you guys in 2 weeks. Bye.
Thank you.
Thank you.
Thank you.
Thank you.